Hello everyone. In this video we'll discuss about the introduction to the concept of chemical bonding. Now chemical bonding is such an important topic, not just for the inorganic chemistry point of view but also for the organic chemistry. So first of all, there are a lot of things that we'll be learning in chemical bonding chapter, but we'll begin with the idea of chemical bonding as such. If you look at the elements, right, only very few of them they have isolated existence. When we say isolated existence, means if you talk about the noble gases, helium, neon, argon, they have independent existence. Means helium will exist as helium atoms, neon will exist as neon atoms in the gaseous state, argon will exist as argon atoms. Xenon and radon also will have independent existence, but xenon, radon, even krypton also, right, we will see that they will be able to form compounds. I mean, they can have independent existence, but they will also form compounds. When it comes to metals, we have some of them, like the noble metals, so-called noble metals, which will be less reactive, like gold, platinum. They also will have isolated existence, but gold also can form compounds. Okay. And most of the other elements, right, when you see how they exist in nature, they will be existing in what we call as the combined form. So combined form means what? The atoms of the element, they will either exist in combination with atoms of the same element or the other elements. So generally this combined form, right, we will talk about the existence in the form of molecules or in the form of the ionic compound. So what is the difference between the two? We will be able to understand as we go into the discussion of the chemical bonding. Okay, but the need to understand chemical bonding basically comes from the fact that most of the elements, they don't have isolated or independent existence, they exist in the combined form. The question comes to why there is a need to have the coexistence, or what we call as a chemical bond. So if two atoms are coming together, means we will say it as what, there is a chemical bond that is getting formed. Okay, that is how we can begin our understanding of the chemical bonding. So the basic question is why the atoms are forming a chemical bond, and there are more questions to follow which will help us to understand the entire chemical bonding concept in detailed manner. But if you look at where the genesis, so it all began with the Dalton's atomic theory. So Dalton's atomic theory is the theory basis on which we will talk about the concept of atom, isn't it? So as per the Dalton's atomic theory, right, the entire matter is made up of small, indivisible, indestructible particles, which are the building blocks of matter. So what do we call them as? Atoms. So atom means what? They cannot cut any further. That is how the word atom has come. And also the Dalton's atomic theory talks about atoms of same element being identical, means they'll have similar size and similar properties, etc. And atoms of different elements, they have different size, different mass and different properties. While there are some more postulates of the Dalton's atomic theory, the one that we are interested from the study of chemical bonding is that the Dalton's theory talks about the combined form, or the existence of the atoms in combined form. So it says that atoms of same element or different elements, they can combine to form molecules or ionic compounds. There is a difference between these two types. We will talk about it when we go into the details of the chemical bond. But here the Dalton's theory talks about the concept of combination. But the question is why atoms have to combine? That is something that the Dalton's atomic theory was not able to address. But it gave the idea of the atoms combining, either atoms of the same element or different elements combining to form the chemical bond. Now the basic questions that surround, which have actually helped in strengthening the understanding of the chemical bonding as such are: one, why do atoms combine? So when atoms are combining, we are saying there is a chemical bond that is getting formed, right? So the question is why atoms are combining. Why can't they have isolated existence? Like some elements, whether it is neon, argon, they are able to have isolated existence, right? Why can't other atoms also have isolated existence? That is one question. Now when these atoms are combining, so how are they combining? We will be able to know. So when we talk about the different types of chemical bonding, right, we will be able to get answers for this. And from the chemical bonding theories, we will be able to get answer for the first question also, like why the atoms have to combine. And the other question is, why are only certain combinations possible? Means what? A carbon and oxygen can form CO, they can form CO2, but they cannot form CO3, they cannot form CO4. So only certain combinations are possible. And the next question is, so this also we will be able to understand once we go through the theories of chemical bonding. Why do some atoms combine while the others don't? See, what we see is sodium will be able to combine with chlorine, but sodium will not be able to combine with magnesium. So why only some atoms combine and the others do not? And when we look at the molecules, right, we will have a characteristic property of the molecules, which is the shape. If we talk about something like a BeCl2, this molecule will have what is called as a linear shape, means the beryllium and both the chlorine atoms will be along a straight line. Whereas a similar formula, H2O, will have a bent shape or non-linear shape. Same formula, here we have beryllium, here we have oxygen, 2 chlorines, 2 hydrogens, similar formula, but BeCl2 is what? Linear, and H2O is what? Non-linear shape. So why do molecules possess definite shape? Why different molecules are having different shapes? And when you look at the properties of the substances as a whole, right, there is a relation between the properties of the substance to the type of chemical bonding that is there. If you talk about, we will see the ionic compounds, right, they will generally have high melting points, high boiling points, they will be soluble in polar solvents like water, etc. So the properties of compounds will be related to the nature of bonding that is there between the atoms. And we will also be interested to know what is the exact relation between the properties of the substances to the nature of bonding. That we will be able to get answers for when we will go into the different types of bonding. So the different types of bonding and the details of what are the properties that each type of bonding will be able to give rise to. So this is what we will be trying to understand in terms of the study of chemical bonding. So if you are able to get answers for these questions, right, then our study of chemical bonding will be comprehensive. Now when we talk about just the idea of what is a chemical bond, we said when atoms come together, like say for example there is an atom of element A and atom of element B, when these two come together we say there is a chemical bond that is being formed. But the chemical bond as such, right, is explained by using multiple definitions. So one is the force method. So what is the force method of explaining chemical bond? So when these atom of element A and element B are coming together, right, there must be some force which is holding them together, right, otherwise they will be moving apart. So this attractive force which is holding these various constituent means what? Either we talk about the atoms or ions. So all the constituent particles, whether atoms or ions, they are held together by some attractive force. If the attractive force is not there, means what? See, you have atom A, there must be some attractive force with atom B, otherwise they will move away, right? This attractive force that is responsible to hold these particles together is what we call as a chemical bond. So this is the definition of a chemical bond based upon the force method. Then we have one more definition, which is what we call as the energy method or the energy concept. Now if you dig a little bit deep into the force concept, right, what we will be seeing is it is not just that you have the attractive forces only. If you have the atom of element A and atom of element B, generally when they are far apart, right, the nucleus of one atom will attract the electrons of the other. Similarly, the nucleus of the second will attract the electrons of the other. So there will be attractive forces. So when these atoms are far apart, what will be happening? There will be attractive forces that will be dominating. But when they come very, very close, what would start happening is the electrons of both the atoms, they will start repelling each other, and nucleus of both the atoms also, they will start repelling. So as a result, what we will see is the repulsive forces will dominate. So when the atoms are far away means the attractive forces will dominate. When they come very closer means what? The repulsive forces will be dominating. So when the two atoms are approaching each other, right, there will be actually how many forces, or rather what are the different types of forces operating between them? There will be one attractive forces and there will be repulsive forces. So you see the distance, the optimal distance we can say, henceforth we will be also calling it as bond length. So what is this bond length? It is the distance at which the attractive forces and the repulsive forces balance each other. So means what? There are attractive forces and repulsive forces. When they both balance means what? It is the kind of equilibrium, isn't it? So that distance is what we are going to be calling as the bond length or bond distance. And you see, in the energy perspective, right, at that particular distance, the energy of that system, which means the two atoms together, you call it a system. At that particular distance, the potential energy of the system is minimum. And think about it, right? Why we say there is a chemical bond that is getting formed? If the two atoms are supposed to move away, means what is happening? Observe this closely, this diagram, right? The energy is basically increasing. If they have to come even more closer means again the energy is increasing. Remember, always in universe, right, things will try to achieve what? The least energy state, isn't it? Because least energy means what? More stable. Like, why water will flow from top to bottom? Because when water is coming from a higher altitude to lower altitude, the energy of the water will be decreasing, isn't it? Same concept. So the energy of that two atoms system is minimum at this optimal distance, which we are calling as the bond length or the bond distance. So this distance, the atoms will be held together. And we can look at it both from the energy perspective as well as the force perspective. At this distance, it is like the forces are in equilibrium. The repulsive force and the attractive forces, they both are basically balancing each other. And the other thing is what? When we try to move them apart or try to make them come even more closer, the potential energy will be increasing. Always, anything in the universe, any system in the universe tries to achieve what? The minimum energy state. And that minimum energy state, we say there is a chemical bond being formed. And if we want to take these atoms away from that minimum energy state, we have to supply energy. So when a chemical bond is formed, that is the minimum energy state. If you want to break the chemical bond means we have to supply energy. We will study a little bit later in the properties of the chemical bond, that the energy required to break the bond. If you have to break the bond and take these atoms to infinite distance, right, means let's say this is some minus 200, like that, you just imagine. If we take them to infinity means energy is becoming what? Zero. Means how much gap we have to supply? We have to supply energy of 200 joules, like that, whatever is the gap. So this energy required to break the bond is what we will be calling as the bond energy. What do you call it as? Bond energy. So what is bond energy? Energy required to break the bond. We will talk about it later, but this is how we look at the concept of chemical bonding by using the energy concept. Okay. Now there is one more approach to explain the chemical bonding, which is based on the stability of 8 electron structure in the valence shell. Okay, so what is this concept of chemical bonding? It is based upon the stability of 8 electron structure in the valence shell. This is what we call as the octet theory. Now octet theory, we'll again study a little bit more detailed about it in one of the theories of chemical bonding, which is the Lewis theory of chemical bonding. Here we'll just try to look at what is the basis of this octet theory. If we look at the inert gas elements, right, except helium, because helium, what is the electronic arrangement? 1s2. It has got a duplet. All of them, they'll have 8 electron structure in the outermost shell. And all of them are chemically not reactive. Of course, we'll see some exceptions in that also, but broadly speaking, what? They are chemically not reactive. So when they are chemically not reactive, it indicates what? That there is some stability associated with this particular electronic structure. with this particular 8 electron structure in the outermost shell. So this is how typically we will represent NS2 NP6. Some stability is associated with this 8 electron structure in the outermost shell. And in most of the cases where we talk about the chemical bonding, the outermost shell electrons only will be participating. The electrons of the inner shells or the inner orbits, they will not be participating in the chemical bond. Only the outermost shell electrons will participate in the chemical bonding. And through the means of chemical bonding, right, the other elements will try to attain this stable configuration of the inert gases. So the chemical bonding basically is what? It's a means. It's a means of achieving the octet structure in the outermost shell. Now how they will do it? They will do it by two means. One is either by sharing of electrons. In that case we will see there will be what we call as a covalent bond that will get formed, or they can achieve this octet structure by the transfer of electrons. Transfer of electrons means we can either have the losing of electrons or the gaining of electrons. Okay, so this is about the concept of chemical bonding using the octet theory. So this is what chemical bonding is basically a means. It is a means to reach this octet arrangement in the outermost shell. Why the elements have to reach octet arrangement in the outermost shell? Because there is something stability associated with this particular structure, which is based on the chemical inertness of the noble gases. Okay, so we will again study about the octet theory in the Lewis theory of chemical bonding, but here just one more perspective of understanding the chemical bonding. Now if you talk about the types of chemical bond that can be there between atoms, right, the types of chemical bond that can be there between atoms will depend upon, of course, the nature of the elements that are participating. So if you have electropositive elements, what are electropositive elements? Typically all our metals. Okay, what is their characteristic property? The atoms will be able to easily give up one or more electrons, meaning they can lose electrons. Okay, why? Because they'll have low ionization potential or low ionization energy, correct? So all these elements are what? Electropositive elements, metals. Then we have electronegative elements, typically non-metals. Okay, non-metals, they can gain electrons, they'll be able to easily gain electrons. Okay, and why they're able to gain electrons? Because they will have a higher value of electronegativities. Like if you look at the non-metals, right, whether it is oxygen, fluorine, chlorine, they all will have what? Higher electronegativity values. They will be able to gain electrons. And there are also elements which have little tendency to either lose or gain electrons, like the case of carbon or the case of silicon. All of them, they will be having what? Lesser tendency to either gain or lose electrons. So this is how we look at the total types of elements. Now depending upon the types of elements that are there, we will have a particular type of bond being formed. Like if you have a bond between electropositive element which can easily lose electron and electronegative element which can gain electron, what will be the type of bond that will be formed? It will be what? Ionic bond. Okay, we'll look at the examples. If you have an electronegative element and another electronegative element, two electronegative elements, there that lose and gain will not be possible. So there will be only the sharing of electrons, that will be what? A covalent bond. Then if it is the case of two electropositive elements, like in the case of metals, if it's a case of metals, right, what is the kind of bonding that will be there? We will call it as what? Metallic bonding. Okay, so depending upon the nature of the elements, the type of bonding is going to be changing. Anyway, so as we go into the next set of videos, we will be able to study in detail about what is the ionic bond, what is the covalent bond, what is the metallic bond. But here what we'll do is we'll take a quick look at the definitions of these ionic bond, covalent bond, metallic bond, and some examples. So what is an ionic bond? It involves the complete transfer of one or more electrons from one atom to another. Like you look at it, what is happening? Sodium is losing electron to form Na plus. The electron is taken by the chlorine to form what? Cl minus. Now the Na plus and Cl minus ions that are formed, right? This is positive, this is negative. These oppositely charged ions, okay, will be attracting each other. So they will be attracting each other by what means? By electrostatic forces. What are these electrostatic forces? In physics you will study about it. Charges, right? If you have a positive and positive, they will be what? Repelling each other. Negative and negative, they will be repelling each other. Okay, a positive charge and negative charge, they will be attracting each other. So the forces between charges is what we will be calling as the electrostatic forces. So here the electrostatic forces will make these oppositely charged ions to come together and form what we call as the ionic lattice. Means it will form a solid structure. What it does, it will be forming a solid structure. Okay, we'll talk about how the solid structure is going to be formed and what will be the energy changes involved in the formation of the solid structure. So ionic bonding is not just about the transfer of electrons. After the transfer of electrons, the oppositely charged ions will come together because of the electrostatic forces of attraction, and thereby they will form a solid structure. That is what we call as the ionic lattice or the ionic crystal, and that is the process of forming an ionic bonding. If we talk about covalent bonding, right? Covalent bonding is what? It involves sharing of a pair of electrons, or we can even have multiple pairs of electrons so shared. Okay, if one pair of electrons is shared between two atoms, right, we will call it as a single bond. If two pairs of electrons are shared between atoms, we will call it as a double bond. If three pairs of electrons are shared between two atoms, we will be calling it as what? We will be calling it as a triple bond. And we will see, like, why the maximum number of bonds between two atoms, right? The maximum number of bonds between two atoms is what? It will be 3. Okay, so why the maximum possible number of bonds between two atoms is 3? You can get the answer by watching the video on the Lewis theory. So we have a lecture video on the Lewis theory. You can look at it and find out why the maximum number of bonds that can be formed between two atoms is what? 3. So here let us come to the concept of covalent bonding. It is what? Involving the sharing of a pair of electrons or multiple pairs. So what is this sharing here? You can see the chlorines, right? Normally they have what? 7 electrons. Now each of the chlorine will contribute 1 electron for the bonding. The remaining electrons of chlorines are what? Remaining, each chlorine will have how many electrons? 6 electrons will be there. Now the concept of this covalent bonding is, this is what we call as the bond pair of electrons or shared pair of electrons. What do we call it as? Bond pair of electrons or shared pair of electrons. Okay, the covalent bonding basic idea is that the bond pair or shared pair will be jointly, the bond pair or shared pair will be jointly owned or possessed by both the atoms. Which means what? Here we have the shared pair, right? It is like the chlorine will be counting that pair of electrons for itself. Second chlorine also will count the pair of electrons for itself. Now you can see, if you count these two electrons, right, what is the number of electrons that will be available on this chlorine? 8 it becomes now. What is the number of electrons that will be available on the other chlorine? 8. We will be able to study more about this representation of electrons on the atoms in a molecule. We will be calling this as what? Lewis structures. Okay, so we have a separate video on the Lewis dot structures. You can refer to it. Okay, but yeah, now coming to the idea of how the Cl2 molecule will exist, you can see this is the shared pair. We can see we are able to represent it on both sides. Okay, it is not like there are two pairs, it is only one pair. Why are we keeping it 2 times? Because we wanted to show that it is like the shared pair of electrons is possessed by both the chlorines, like that. Okay, so this is the concept of covalent bonding. So covalent bonding, because of sharing, right, we will see that both the chlorines are able to reach what? Octet. Okay, so this is how the covalent bonding will basically happen. Now coming to the metallic bonding. So what is metallic bonding? If you talk about the metals, how they will exist, they will be existing in the metallic bonding form. So what is a metallic bonding? Metals generally will have a tendency to lose electrons. So in metallic bonding, what we see is the valence electrons will come out of the metal atoms and they will be free to move throughout the whole crystal. You can see the blue dots are what? These are the electrons that have come out. So what are we calling it as? It is like a sea of freely moving negative electrons. And since the metal atoms have lost electrons, they will now be possessing what charge? Positive charge. So it is like this. Each electron is negative. It is surrounded by positive charged metal ions. So this negative charge electron will be able to hold. So sea of electrons will be able to hold metal ions together, and this is what is the basic idea of the metallic bonding. And the availability of these free moving electrons, which we of course also call by the name mobile electrons, the availability of the mobile electrons, right, is the reason for metals being good electrical conductors, as well as they also conduct heat better because of the availability of the mobile electrons. Okay, now the thing is metallic bonding, right, we'll anyway study more about it later, but the metallic bonding, it will depend upon two important parameters. The strength of metallic bonding, rather the strength of the metallic bonding, right, it will depend upon two factors. One is the number of electrons that are released. So think about it. If more number of electrons are released, means what? That electrons will be able to hold the atoms more tightly. Okay, and the size of metal atom. Okay, so if the metal atoms are bigger, means right, if the metal atoms are bigger, it will be difficult for the electrons to hold them. If the metal atoms are smaller, means the electrons will be able to hold them better. So the strength of metallic bonding will depend upon what? Number of electrons released. More the number of electrons released means what? The bonding is going to be more stronger. Size of the metal atoms is lesser, means what? The metallic bonding is going to be more stronger. Okay, so this is about the concept of the metallic bonding. Now in terms of the overall coverage of the chapter, what is it that we are going to cover? So starting with the theories that will try to explain the covalent bonding, beginning with the Lewis theory. So where there are multiple approaches. One is the Lewis causal approach, which mainly talks about the electrovalent bond, which is later going to be called as the ionic bonding. And there is the Lewis-Langmuir approach. So Lewis-Langmuir approach is mostly to deal with the covalent bonding. Okay, so the Lewis theory is based upon the idea of the octet rule. Okay, so basically the Lewis theory talks about why atoms are combining. Obviously the reason is so that the atoms can reach the octet arrangement, and also with the help of Lewis dot structures, right, we will be able to understand how the atoms are arranged in a molecule. Means which atoms are bonded to which other atoms and things like that. That we will be able to understand from the Lewis dot structures. So the Lewis theory is what? It will be able to explain why atoms are combining based upon the octet rule, and also it will be able to provide us information on what is the arrangement of atoms in a molecule. Like say for example, if you have a molecule like AB2 E4, we have just some random example I am taking. So there is one atom of A and two atoms of B and four atoms of E, like that. Okay, now how these are bonded? So is it like A is bonded to one B, or A is bonded to both the B's? So what is the kind of an arrangement of atoms that is there? That we will be able to understand from the Lewis dot structures. But there are some more parameters of the bonding that Lewis theory could not explain. And the next theory, valence shell electron pair repulsion theory, which in short we call as the VSEPR theory. This theory will help us in understanding the shapes of the molecules and also the bond angles. So when you have like say central atom is there, it is forming multiple bond, means what will be the bond angles? This is something that we will be able to understand based upon the valence shell electron pair repulsion theory. Then we have valence bond theory and molecular orbital theory. Both these theories, right? See, Lewis theory and VSEPR theory, they consider the classical model of the atom, which means atom is consisting of electrons, particles. But the valence bond theory and molecular orbital theory, right? They both are based on the idea of quantum model of the atom. Both these theories are based upon what? They both are based upon the quantum model of the atom. Okay. Valence bond theory again will be able to explain the bond angles concept. It also will be able to give us information or insights on how different bonds will have different bond energies and how different bonds will have different bond lengths. So VB theory or valence bond theory in that sense will be able to explain most of the parameters of the chemical bonding. So all this, we are discussing in what context? In the context of the covalent bonding. But still there are some properties like magnetic properties, especially some particular examples like O2 molecule, right? All the previous theories, they predict that O2 will be what? O2 will have no unpaired electrons and hence O2 will be diamagnetic. That is what all the previous theories will predict. But experimentally what is found is O2 is actually having paramagnetic nature. So generally paramagnetic nature, right? It will come when there are unpaired electrons. Certain properties like this, which could not be explained by the previous theories, the molecular orbital theory will be able to provide us explanation. Okay, so it will be able to explain how O2 will have paramagnetic nature. So we'll study more about it when we go to the molecular orbital theory. Okay, then we'll also look at the ionic bonding separately in detail, like how the ionic crystals will be formed, starting from the formation of the cations and anions. We'll also look at the metallic bonding, and then while we talk about the bonding in a molecule, the forces between the molecules, so molecule 1 and molecule 2, there will be forces which will be between these molecules. We will call them as what? Intermolecular forces. Intermolecular forces will also be responsible for some properties like melting points, boiling points, etc. So what are these different types of intermolecular forces and how they will give rise to certain properties of the substances? This is something that we will be able to understand from the last part of the chapter. So this is what we are going to be covering in the entire chemical bonding. So as you can see here, we will be able to cover lot of aspects related to the inorganic chemistry chapters as a whole. Okay, and that's the reason why even when you look at the competitive examinations, right, this chapter is considered as a high weightage chapter, because we will see that the questions, right, chemical bonding is a concept, so we can have questions corresponding to different groups. Like we can have a question coming on the p block elements but related to the chemical bonding theory. We can have a question coming on the D and F block elements but related to the concept of chemical bonding theory, like that. Okay, so that's the importance of the chemical bonding, and we will see in the further videos as to how we will learn each of these things step by step.